Histograms.
Whoa.
Histograms look like a bar graph, but ... They look like a bar graph. They are often confused with a bar graph. In fact, you guys often make bar graphs in classes, and your bar graph is not a bar graph. It's technically a histogram.
Uh-oh.
We just make them on accident sometimes.
Yeah.
That's true.
Because in a histogram, the bars or the columns, the up and down thingies, sometimes you can have a vertical or a horizontal, but touch. Technically speaking, a bar graph, the bars do not touch. There are spaces between the bars. For example, there should be spaces between them if it's a bar graph. In a histogram, they all touch. There's no gaps between the bars. The other difference is the X values. So on the bottom, the label, are ranges. So like if I was making a bar graph is typically used, for qualitative data. You can use it for quantitative, but it's a little bit harder. But qualitative data. If I was going to make a bar graph of everybody's favorite color, right? I'd have a bar that represents people who said red, and a bar that represents people that said blue, and a bar that said purple, right? I'd have a bar for each one. A histogram, my X value, instead of it being, colors, are ranges. So if I was going to do,
How many people per group said this?
well, that's a qualitative. I need quantitative data. So if I was going to do how long your commute is to work or to school, how far away you live from school, right? My first range would be 0 to 5 miles, right? Really, I'd probably do 0 to 4.9 miles. And then my next range would be 5 miles to 9.9 miles. And my next range would be 10 miles to 4, right? I have ranges. Because I have too much data to do individual, I have to group them together in their frequencies. Like yesterday when we did frequency tables, right? My ranges, my X values would be ranges, not just one item. It would contain a multitude of information. So the X values are ranges, and just like yesterday, that range should be constant or equal, right? If you're going to do 0 to 4, that includes the numbers 0, 1, 2, 3, and 4. That's 5 values. So my next range needs to include 5 values. 5, 6, 7, 8, 9. When you're figuring out these ranges, when you're figuring out your ranges, there is no shame in counting on your fingers to make sure that you're including the right number. These are called bins. These ranges in a histogram are called bins.
It's a bin full of stuff.
full of stuff because it's got multiple things inside of it. So we're going to practice making some histograms.
Yay.
Oh, I'm sorry, yeah, please now. Let's start swinging.
I'm going to read you a list of data.
I don't know.
Remember, it's easier if you don't try to look back and forth, up and down. Just listen to the
That's
numbers.
exactly what it is. Oh, I'm gonna have a hard time. It's gonna be your fault.
You're going to be okay. I'm going to start reading the data in 10 seconds, so get ready.
What if a kid has is like a
Oh my gosh.
Yeah, is that you?
Here we go. 10,
Oh no.
15, 20, 15, 16, 20, 18, 34. I'm starting a new row. 9, 10, 17, 25, 26, 28, 30, 31. Finished.
Woo!
All right, so
I have a question.
in order to make a histogram, we have to first make a frequency table. We have to determine how many pieces are going to go into each bin width. So I need to come up with my ranges, my bins. It does not have to start at 0. We can make a broken graph, right? We can do our little at the beginning and make it a broken graph.
Let's do 5.
So I'm going to start with 9 because that's my minimum. And I'm going to do 9 to 15. How many values are in that bin?
1 right now.
So count on your fingers. Ready? 9, 10, 11, 12, 13, 14, 15. How many values are in there?
7.
7. So my next bin width must contain 7. So I have 16. Now let's count it out again. 16 is number 1. 17, 18,
22.
19, 20, 21, 22. That's 7 values. My next bin is 23,
29.
23, 24, 25, 26, 27, 28, 29. And then the last one is 30, 30, 31, 32, 33, 34, 35, 36.
I thought it was going to go to 37 because there's 7.
There are 7 in there, but you have to include the first value. If you did 30 plus 7, it's not including the number 30. You have to include the number 30.
Can you tell that to the people who think that the end of the decade is after this?
There you go. So here we go. How many values are between 9 and 15? So 1, 2, 3, 4, 5. How many are between 16 and 22? So 1, 2, 3, 4, 5. 5? $23 and $29. 1, 2, 3, 3.
Oh, yeah.
And then 30 and 36. 3. So now I'm going to create my histogram. It starts out like a bar graph. My X are my bins. So 9 to 15, 16 to 22, 23 to 29, 30 to 36. Those are my bin widths that I came up with. Then let's see, 2, 4, 6, 8. Does that work? And 9 to 15 is 5. You can color them in if you want. I don't really care. 16 to 22 is also 5. So they touch. Because there is no gap in the data. It's continuous, right? Like it's going from one value straight to the next. 23, so that's 3. The next is 3. Histogram. It's like a bar graph, except the bars touch, and the X value, instead of it being one single item per bar, it's a range. It's a grouping. No, we have one more. The thing about histograms, which we will get to, is that histograms, just like everything that we've been talking about data, right? It can look a little bit different because it's an interpretation of the data, right? It's your interpretation. Is there a wrong way to interpret it? Yes. But can data be manipulated to look differently? You bet. I can use this same data and create a completely different looking histogram by changing my bin width. If I change my bin widths to 9 to 13.
So that's 5.
So 9, 10, 11, 12, 13. 5 pieces of data. Instead of 7 pieces of data, I just knocked it down to 5. So what would be my next bin width? 14 to 18. 19 to 23. 24 to 28. 29 to 33, good. And I don't need to go higher than 38, right? Hold on. My largest number is 34, so I'm good. All right, how many pieces of data fit in the 9 to 13 column? 1, 2, 3. How many 14s to 18s? 1, 2, 3, 4, 5. 5? 19s to 23s. 1, 2, 2. 24 to 28. 1, 2, 3. 29 to 31. Oh, right there, 2. And then 34 to 38. 1. My data frequency table looks completely different, correct?
Yeah.
But it's the same data.
Uh-huh.
My histogram, 9 to 13, 14 to 18, 19 to 23, 24 to 28, 29 to 33, 34 to 38. Ooh, I ran out of room. 2, 4, 6, 8, 10. So I've got 3, then I go up to 5, then I go down to 2, I go back up to 3, I go back down to 2, and then I go to 1. I mean, it's the same data. I just changed the way it looks. The trick is, it happens, and we'll talk about what that looks like, or what that means. But we try not to have any gaps. Sometimes you can't help it, because if I added one more piece of data up here and I put 87,
That'd be really far.
it'd be really far, right? It's an outlier, right? This would be an outlier. It doesn't belong, right? So there'd be a gap. I wouldn't include that in my data, because if I had to include 87 into my ranges, right, like you'd be talking about like having 40 numbers in a range to try to make it work. And that's ridiculous. So we try not to have any big gaps, right? We try not to make a table have a 0 value in our frequency, but sometimes we can't help it because there's this number that's so ridiculously out of control, too big or too small. Try to make no 0 values. Sometimes you can't help it. Sometimes there's a number that just does not belong. Questions about histograms?
Nope.